The next question in this exercise, question 13.1.7. To find out the concentration of SO2, that's sulfur dioxide, in the air, which is one of the pollutants, by the way, in parts per million, ppm in short, the data was collected for 30 localities in a certain city and presented below. Find the mean, which is average, concentration of SO2 in the air. And you have been given some table. There are 4 such localities whose sulfur dioxide combination concentration is between 0.00 and 0.04, and 9 such localities between 0.04 and 0.08, and so on. So here we are going to use the weighted average method. In that case, first, now we don't know whether these 4 are exactly where they are. They are somewhere in this range, 0.00 and 0.04. So we are going to take the average, which is nothing but midpoint of this range, and we are going to create a new column. Let's call it as midpoint xi, which is nothing but the midpoint of this range, because this is a class interval. We do not know where exactly these 4 observations are lying. They can be towards the lower end, towards the upper end. So we are going to pretend that they are exactly in the midpoint. So we are going to take midpoint for accurate and precise calculation. So that would be 0.02, which is the average of these 2 values. Then 0.06, which is average of 0.04 and 0.08, and so on. So I'm going to get like the midpoints of each value in the first column, and I'm going to mark that as xi, x suffix I. Remember, this is fi, which is frequency of individual observation, individual class interval. Now, all we have to do is like multiply this with this one, because we are going to create another column, which is like fi xi. That would be 4 times 0.02, that will give us 0.08. 9 times 0.06, which is 0.54. 9 times 0.10 is equal to 0.90, and so on. So we are going to multiply, because the column says fi xi. That would be fi is the frequency column, individual. Xi is the observation column, which is individual, again, concentration at that locality. And we are going to eventually add all these fi xi. So that would be sigma, which is a typical notation used for total, summation, addition. And if you add these all values, they will come out to be 2.97. We know that summation of all frequency values is 30, and that should match with 30 localities given here. So it's a matter of like using the appropriate formula. We are supposed to calculate the mean, and that x bar, which is notation for mean, is given by summation sigma fi xi divided by summation of fi. We are going to distribute that the first moment, which is fi xi, among all the frequencies, and that would be 2.97 divided by 30. Now, dividing directly by 30 is difficult, so I'm going to cancel 1 0 from the denominator, and to compensate for that, I'm going to shift the decimal point towards the left, which is as good as dividing both numerator and denominator by 10. So instead of dividing by 30, I will write it's 3, and instead of dividing by 2.97, this will be shifted 1 decimal to the left. Now, if you divide this one, that will come out to be 0.099. The units will be parts per million, that is ppm, and that's your final answer.